Good evening, everyone. My name is Bolen. I know most of you here. I have done my senior capstone project on cognitive neuroscience for academics. So specifically, I've taken it upon myself to look at the brain sciences behind academics through memory and attention. Now, my inspiration behind choosing this topic comes from many places. One of them being that I myself am a student. I can use exactly what I've been researching to apply to my own life through the rest of high school and college, but the other part being that I can share all this information with you. I know there are a lot of students in the crowd that will also find utility in what I've learned. So first of all, can you guys hear me all right? Is that better? Yes. Cool. My essential question reads, how can students use an understanding of cognitive neuroscience to achieve their academic goals? First, it's important to define cognitive neuroscience for everybody here, even I wasn't familiar with the term when I began my research. Cognitive neuroscience is the scientific field studying the biological mechanisms underlying mental processes, bridging brain science, neuroscience, and the mind, cognitive psychology. My research has been specific to adolescents and academics, but if you fall outside of either of these categories, I still think you'll find what I have learned pretty interesting. Now, for my field work, which was one of my favorite parts, I got to visit Switzerland. Now, I chose Switzerland because of the research that the University of Zurich and the University of Geneva are doing. The country is a global leader in neuroscience research. While I was there, I spent time in Zurich, Bern, and Geneva, and got to go sightseeing and even skiing in between my interviews. Beginning in Zurich, I first met with Dr. Charlene Palo, a postdoc at the University of Zurich. Her research focuses on how the brain stores memory and information by taking readings on electrophysiological signals in the brain. Then in Geneva, I met with Dr. Celine Hiradet. She's an expert in educational psychology and works with students she is an expert in educational psychology, like I said, and works with students of all ages, and also does research on assessments and how that impacts academic performance. Then I met with Dr. Iliara Sani, who showed me all about what is happening at the University of Geneva, what research they're doing, more about that cognitive neuroscience. And then I had a great conversation with Dr. Anne Yen Danse about media use and its impacts on adolescents in academics. In addition to my interviews, I used a book called Uncommon Sense Teaching, which I got great insight from to support my interviews, and I'd highly recommend it to all the teachers here. Essentially, the goal of this project was to learn as much about memory and attention to turn an understanding of these concepts into tools for students. But before I give you the results, we have to get into the science. The perfect place to start is with the neurological basis of memory. Each of our brains contain around 86 billion neurons, and we store information by making connections between these neurons. When we try any new task, whether it be riding a bike, learning a new concept in math, or interacting with new information, our brain creates weak links in the brain that can easily be lost. And if we want to keep that information around, we have to do what's called link it. And I'm going to talk about learn it, link it as a concept all throughout this presentation. Perfect. What learn it, link it is doing is bringing information from our working memories through our hippocampi into our long-term memories. Working memory is another term for short-term memory. And this form of memory can only hold on to so many pieces of information at a time. Research suggests that we can only retain about 4 to 7 pieces of information depending on the complexity of that information. Now, in contrast, there's not really a limit to how much information we can store in our long-term memory, but rather how easily it can be accessed. And in an academic context, students are often asked to get large amounts of information into their long-term memory and then recall that for assessment purposes. Now, many students may fall into the trap of learning information in their working memories and then losing it when it comes time to either assess it or retrieve it. Don't be frightened by the octopus in the front of your brain. That's not real. That just represents your working memory, and it's juggling those pieces of information. Getting information into your long-term memory takes time and repetition. Academically, the first exposure we have to information usually comes in the form of direct instruction. This could be through a lecture or a form of media like a book or a video. Now, this exposure isn't impactful enough to have a lasting impact on students. And the best way to combat this is by turning an initially passive learning technique into active learning. When you ask a question or clarify your understanding of a topic in class, or let's say interpret something in your own words, you're strengthening those connections between your neurons. One of the best ways to get into information into long-term memory is actually to recall it. This can be done by turning and talking to a classmate or revisiting that topic when you go home to do its homework that night. These activities force your brain to recall information and apply it to the task at hand. And if we want information to be accessible in the long term, we should recall it over an extended period of time. For example, reciting a deck of flashcards once a week over the length of a week is going to be a lot more effective at getting information into your long-term memory in your neocortex rather than, let's say, reciting that deck of flashcards 7 times just the night before. Now, while some students can rely on their short-term memory and their hippocampi to pass a test just by cramming beforehand, research shows that information retention plummets if you learn in this manner. Now, we all know, did I miss a slide? I did not. Okay. We all know that we can't focus forever and that we need breaks. Interestingly, our brains don't actually stop learning when we take these breaks. When we disengage with the task or are sleeping, 2 really cool things happen. 1, our brains are severing unnecessary connections that we've made in the learning process. You can see that in the photo to the left here. This is more general to brain pruning as we age, but it's a good visual, and you can think about it like Google Maps optimizing a route for you from, let's say, home to school. The second thing that happens is called hippocampal replay. This is what happens when you sleep specifically. And what's happening is your hippocampus is repeating information to your neocortex, that's your long-term memory, like you would repeat someone's name after just meeting them so you won't forget it. Now, while these 2 things are really cool, it just emphasizes how much we need to prioritize both taking breaks and sleep. We also have to understand that our brain stores memory in 2 different ways. The first of these pathways is called declarative memory. Now, this memory uses the hippocampus and the working memory to interface with those, like that library of long-term memory used for things like facts and dates. It's mostly conscious, and you're explicitly aware of what you're learning and thinking about. It answers questions like the who, what, where, and the when. And on the other hand, procedural memory is largely non-conscious. This is the memory that takes care of the how. If you're learning to ride a bike, you aren't consciously aware of every muscle that's firing in your body, and you couldn't explicitly tell someone how you're riding a bike. I'll take giving this presentation as an example. I want to have my script memorized via procedural memory because it requires less working memory capacity, but I also want a declarative understanding of my topic in case one of you guys asks me a question. Now let's talk about attention, because without it, none of the memory processes we just covered can happen. Attention is the brain's filtering system. Imagine your brain as the recipient of constant flows of information from your senses, but not all of it is equally relevant at any given moment. The attention system amplifies what matters and suppresses what does not. And there are 2 major types. Endogenous attention is goal-directed. This is also known as top-down attention, meaning that you voluntarily decide to focus on something like studying or getting work done. On the other hand, exogenous attention is triggered from the outside, where a sudden noise or vibrating phone pulls your focus automatically. Endogenous attention, that goal-directed attention, can be supported by minimizing distractions and using stimulation wisely. One of my biggest takeaways from this project is that there is no one-size-fits-all for memory and focus, and that some people might do really well with things like caffeine and music for stimulation, while others may require silence to focus. Now, while we all may know what multitasking is, it's actually a myth. Every time you switch attention from one task to another, you pay a cognitive cost. What feels like multitasking is actually your brain switching rapidly between tasks, and it makes it harder to fully re-engage with what you were doing before. The more mental energy we spend switching between tasks and managing distractions, the less capacity we have left for the thinking that actually matters. Now, moving on to procrastination. If you're anything like me, you're pretty familiar with this topic. Putting off a task because from the outside it either looks demanding or you convince yourself that you have time later. Getting the ball rolling often proves as the hardest part of these tasks. So take some advice from Dr. Hiradet and start small. Committing to working for 10 minutes on a project that will take hours is manageable, and once you overcome that inertia, momentum takes over. 10 minutes can easily turn into an hour once you're already working, and even if it doesn't, something's always better than nothing. Another tool is to break things and big projects down into smaller parts. This lowers the barrier that comes with starting a task, and the accountability through multiple deadlines proves to lower the day before panic that we all experience. Now for habits. Our brains process repeated behaviors very differently from one-off actions. As a behavior is repeated, it becomes increasingly autonomized, requiring less conscious effort each time. Building a new habit takes roughly 6 weeks to 3 months of constant repetition, but breaking a habit is a different thing entirely. Now, when we're crafting our habits, whether that be academically, if we always want to do work at a certain time in the day, or we want to, let's say, stop pulling out our phone when we're bored. We need to recognize the cues that we're given, and instead of just suppressing those, we need to give it an alternative. Now, for students, building in routines and schedules can be a pivotal investment in academic success, and I'd highly recommend it if you are working towards one of those big academic goals. Now, while talking with Dr. Nyen Danse, I learned about how the brain interacts with different types of media. Specifically, when we interact with short-form media, the brain becomes conditioned to expect quick rewards and finds it harder to engage with those slower tasks like reading or studying. And additionally, stimuli like notification trigger our exogenous attention systems, taking away from our focus. So a good rule of thumb is to leave your phone outside of whatever space you may be studying or getting work done. Limiting the consumption of these kinds of media can also support a student's ability to focus over a longer period of time. Now for the strategies. Starting with space practice, we learned that to retain information in the long term, we needed to learn it in the long term. This is super important if you're trying to retain lots of information, let's say for a big test, that's something that can't just be studied the night before. The most effective way to get information from your working memory into your long-term memory is that active recall. It's super helpful to apply your understanding and create stronger links between those neurons in your brain. Now, this third method is actually really interesting, interleaving. Now, this is when you take multiple topics, let's say both science, Spanish, and math, and you are studying them all in all at one time, alternating from one to the other. This is one, making really strong connections between those neurons in your brain, but also forcing new neurons to grow and create connections between the ones that have previously existed. Of course, sleep and breaks are super important. Who doesn't love those? I don't think I need to preach those to any of you. But the fifth one would be to limit distractions. Now, I know, of course, I'm a person that does really well with stimulation when it comes to performing certain kinds of tasks. But to heighten your endogenous attention systems, it is incredibly beneficial to limit those distractions in whatever environment that you're in. And lastly, to build routines. Because there is a minimized cognitive demand to starting a task when it's already a habit, it makes it super easy to, let's say, get into a focused mindset if you're trying to study, if you're trying to get work done. So recognizing what your goals are and tailoring your habits to that can be incredibly helpful. And for my essential answer, with a basic understanding of cognitive neuroscience and memory and attention, students can adapt the way they learn to study to achieve their academic goals. Thank you. Questions?